Alright, so here's a video reviewing how to translate graphs from position to velocity to acceleration, or vice versa. Again, these three types of graphs, once we have one, we should be able to interchange the other two. So to start off, position versus time graphs, the slope of these, well, that equals the velocity. So if I'm looking at a x versus t graph that looks like this, well, I look at this, slope, 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 all the same, all positive. So the velocity here then would be constant positive slope, constant positive velocity. Okay. Now, velocity versus time graphs, the slope here is acceleration. So again, very similarly to what we're doing here, if I have a velocity time graph and it looks like that, again, positive constant slope, well, that means that my acceleration then will be a constant positive acceleration. Okay, because again, these 3 points should line up: positive, positive, positive slope, positive, positive, positive acceleration. Now, if I want to go back, say from an acceleration to a velocity, well, the area underneath tells me the change in velocity. So this area here, if we were quantitative, would represent this change in velocity. Likewise, the area underneath here, okay, well, that area underneath the velocity graph represents the displacement, which would be from here to there. Okay, so they're interchangeable. Now, here's the other thing that I use and I think is pretty effective in teaching you guys about this stuff, and that is when we have x versus t graphs that are accelerated. Okay, you can have some form of curve that looks like this, and again, I remember that this type of curve is a positive acceleration graph, whereas other accelerations graphs may be some form of this type of curve, and again, that really easy to remember, negative a. Now, some people have a hard time because often you don't have that whole curve. Often you'll have something like this, or you'll have something like this. Okay, again, be able to differentiate what's happening here. We just look at slope to figure out velocity. So I like to take these 3 points, 1, 2, 3, and I know the velocity at that point, real negative slope, therefore the velocity is negative. Here, slope is 0, so the velocity is 0. Here, the slope is very positive, so the velocity is positive. So we're talking about, for this one, we're going from some negative velocity to 0, and from this one, we're going from some 0 velocity to some positive velocity. Okay, and we can do the same with this one down here. Again, we can break it into two parts. Okay, it can look like this, or it can look like that. Again, both of these again are x versus t graphs. So here, positive slope, here, slope of 0. So for this graph, I'm going from v is equal to a positive number to v is 0. Go from here down, v is equal to 0 to v is equal to some negative number. Okay, that's important to remember when we go back to this type of graph translation. Okay, so I have a couple examples I want to work through with you guys, and hopefully this will help you with your translation of graphs in the future. First part, again, we want to go from x versus t to v versus t to a versus t. If I have x, the way that I go from here to here is by looking at the slope. And again, I always often talk about use this 3-point method. Draw 3 points on any portion of line that has constant motion. This portion of the line is constant motion. And so I look positive slope, positive slope, positive slope. They're all the same positive slope. So I'm going to draw in right underneath where these lines, dots are, points that represent their positive slope. Now, this point serves double because it's also on the line that has a slope of 0. So this here, again, is a slope of 0, so it's a velocity of 0. Slope of 0, velocity of 0. Slope of 0, velocity of 0. And so that would be your velocity versus time graph. Now, excuse me. If we go from velocity to acceleration, again, we look at the slope of our points and use the points. Okay, so this is 0, which means it gets taken down to 0. Again, that slope is 0, taken down to 0. That 0. And again, we do the same thing for these 3 points. 1, 2, 3. All 3 slope of 0. So again, all 3 are on this curve. Okay. Again, so this is all constant motion. Object moves in the constant positive direction for a period of time, then stops for a period of time. Here's another example. Again, 3-point method, in my opinion, is the best way to do this. Okay, so first one, positive slope, very positive slope. Second one, positive slope, less positive. And the third one is a slope of 0. Again, I already recognize that this is some form of that curve, which means there's my positive velocity, there's my 0 velocity, there's my negative velocity. Likewise, if you did have some curve like this one, again, I'd use the 3 points here. This is a negative velocity, this is a velocity of 0, this is a positive velocity. Now, when I have a point like this where I know the slope is 0, I automatically start with that point and know, okay, velocity is 0 here, needs to be on the axis. Then I look back and I say positive, less positive, 0. So I'm going to go from a positive, a big positive, to a less positive, to a slope, or a velocity, excuse me, of 0. Then, looks like I go from that to a slope of, well, a negative slope, negative slope, negative slope. This is a constant negative slope. So I'm going to jump down. At this point, it becomes a negative velocity, same negative velocity, and the same negative velocity yet. So my curve would look something like this. Now, this type of curve is actually almost impossible to happen in real life, but for the purpose of our exercise and for the purpose of following our rules, we'll go with it. Lastly, negative slope, negative slope, negative slope. So velocity, well, looks like our acceleration is negative because negative, negative, negative. Again, think about it. Positive to 0. That's a negative acceleration. Then I go down here. 0, 0, 0. Slope is 0, 0, 0 for those points. There's my acceleration curve. Now, sometimes we actually will go from velocity to other graphs as well. Okay, that's an A, sorry. Again, we're comfortable doing this because this is the way we've learned it, and I think this is the easiest way to follow, but you're probably going to be reluctant to go this way, okay? And if you are, that's fine. Again, just follow the process that we've been following. 3-point method. Negative, same negative, same negative. So I'm going to go ahead negative, negative, and negative. That's for my first portion. Positive here, same positive there, same positive there. So that's going to jump right back up. Positive, positive, and positive. Now, going from here up to there, that's going to be tricky. Okay? But again, we can take a look at this and we can think of it negative acceleration. So I know that portion right there that I have kind of circled. That portion right there is a negative acceleration. I know it's going to be some form of that graph. I also know it starts at some negative or positive velocity, which would be here, and goes to 0, which would be there. So I'm going to go ahead and I'm going to draw this. Here I should have a very big slope, and then when I get to this point, I should have a slope of 0. So here's my curve right there. Again, that's this portion of our slope. Now again, you take a look at this slope is positive, so this portion here, when I'm translating it out, should be some form of this graph up there. And so I go from 0 to some positive number, so here's 0, slope of 0, to some positive velocity. So this right here is looking at that portion of our positive graph. So I need to make it start at 0, and I know that when I get to this point up here, we're going to be moving at some positive velocity. So something like that. And that would fit our graphs. Again, the biggest thing here, guys, is to realize that we use slope to translate from x to v, and slope to translate from v to a. Okay. Also remember these two pieces. Okay, the positive x versus t graph. Again, this is negative, this is 0, and this is positive if we're talking about velocities. Okay. And again, if this is my x versus t graph where I have a negative curve, that would be positive. 0, that would be negative. Those things should be helpful, and hopefully this is your key to doing well in the future. So again, take a look at this again if you need to. Otherwise, like always, email, let me know if you got any issues. Thank you, and have a good day.